All right, welcome everyone to Change Notice Unsnapped. Super excited. We're taking about the MacBook Air M2. We've got some new hosts on Team Teardown, so it's going to be a great session today. So we're going to wait a few minutes to let everyone trickle in. But two things first here, make sure your chat function is actually sending to everyone. Zoom still has not fixed this for me. So bottom right corner, send to everyone. And we'd love to hear where you're calling in from. And since today's theme is laptops, we're going to actually rewind a little bit. Tell us about the laptop that you have owned the longest. And the caveat there is it has to actually still be working. Working laptop that you've owned the longest. Let's start with Team Teardown here. Let's go with Will Borzon.
Hi, everyone. The laptop that I've had the longest, I think I'm gonna have to go with the 2013, 2014 MacBook Pro. Yeah, just used it for everything for many years, no problems whatsoever, and it's still working. Gave it to a friend who's in college, and he's still using it to this day. So yeah, it's almost its 10-year anniversary, which is going strong for a laptop. What about you, Will G?
Yeah, thanks. Well, I had bought this premium spec laptop for school that after 3 months met an untimely demise with water. And after that, I bought a minimum spec MacBook Pro in mid 2010 model. And that laptop lasted for at least a decade. It was really funny because there were a few years where once I had started working, I wasn't using it anymore, and I was using my work laptop, and I pulled it out 4 years later, literally had not turned it on in 4 years and still worked fine. Was able to run, a decade-old browser, and it really makes you notice how much software has changed when you haven't touched a browser in 4 years.
That's pretty impressive. I see Joel's got the Sony Vaio, rocking that for 7 years. That's pretty solid. I've had some MacBooks that have lasted a long time, but predating that, my first college laptop was a Lenovo ThinkPad, one of the black bricks with the little nubbin mouse in the middle. And I actually fired that up the other day. It still turns on. This is 10 plus years later, which is super impressive. I remember the one really interesting feature. This is back when we actually had spinning hard drives. There was an accelerometer in the laptop, and when you were to drop it, it actually sensed it and it stopped the hard drive from spinning before it hit the ground, so that it didn't damage the hard drive. I thought that was the coolest thing ever. I'm going to credit that to that laptop surviving college.
Do you miss the nubbin, Tobias?
That is a hot debate. That is a hot debate. I would love to hear from the crowd here. I'm fully embracing the trackpad, but what are people's opinions on the little red nubbin mouse in the middle of the keyboard? Should it make a comeback?
Well, we'll have to see if it made it to the air.
All right, awesome. Welcome Ron with the Dell Studio from 2008. All right, awesome. Let's get started here. We got a packed agenda ahead. So again, welcome everyone to Change Notice Unsnapped. This is our monthly teardown series. We're discussing all things electronics, supply chain, and manufacturing. I think this is our 16th teardown, which is great. We got a lot of regulars in the crowd, so welcome back, and welcome as well to all the new folks joining our community here. Quick reminder, if you do need to duck out, please fill out that survey at the end. That's how we make sure that the next teardown is even better. And so before we get started here, as with all our teardowns, we don't have any insider knowledge on this MacBook Air. All we have is a team of mechanical engineers that are going to hypothesize about all the design decisions that they made here. And so let's go ahead and kick it off with some intros for Team Teardown here. You'll notice one of our regulars, Chris Lee, is not with us today. He's got some super exciting family news. He actually grew his family, so congratulations to Chris if you watch this recording. But with that, we get to bring in some new members of Team Teardown, the Will duo. Give a little introduction of yourself. Let's start with Will Borzon.
Hi, everyone. My name is Will Borzon. Been an instrumental for, coming up on 2 years now. I'm a mechanical engineer by training, product design engineer at Instrumental. And before joining Instrumental, I was a design consultant at Formation Design Group. So I have a lot of experience in a pretty broad set of industries, from aircraft interiors to medical devices. And I'm super excited to dig into the MacBook Air today, because I feel like it's kind of the closest thing we have to alien technology. So I hope we can uncover some really cool stuff today. I'll pass it off to Will.
Thank you. My name is also Will, so 2 Wills for the price of 1 today. And this is not my first teardown. I think I've done 1 or 2 now with the team, and excited to dig into another one. My background, I was a product design engineer at Apple, so always enjoy taking apart Apple products and appreciating all the hard work that the teams there put into those products. But I use that experience to work with a lot of customers, so I can hopefully share some stories today of how customers are tackling some of the problems that they probably faced when making this product. So excited for the MacBook Air today.
All right, welcome Will and Will. And I'm your regular host, Tobias. Again, background in product design. Spent about 6 years working on iPhones and watches at Apple, and super excited to dive into the MacBook Air today. Again, little background on Instrumental for the new folks here. It was founded by two ex-Apple engineers, Sam and Anna, that had experienced firsthand how difficult it was to bring a new product to market. All of the man hours, the failure analysis, the flying over to China, and they set out to build a tool for hardware engineers to actually build better. And so we'll tell you a little bit more about how Instrumental actually works later on, but that's just a little background. So without further ado, for the folks that just joined us here, we're about to jump into the teardown. Please go ahead, introduce yourselves in the chat. And since the theme is laptops, tell us about the longest lasting laptop that you've owned. And with that, let's dive into it. Borzon, let's take it away.
Yeah, let's do it. So we have here the 2022 MacBook Air M2. Yeah, let's just take a look around. What do we have? So I guess the biggest jump here that you'll immediately see is kind of the ID. So the Air was previously, I don't know if you have seen photos of the Air, it's like very narrow in the front. It was kind of like, yeah, this like kind of thicker in the back and kind of tapered forward. And they've since made it like kind of a constant thickness to kind of match the ID of the new MacBook Pros. So yeah, I think one interesting thing is that the overall thickness of this new MacBook Air is, I think thinner than the previous one, but they kind of took some of the density out of the back and moved it over to the front. So yeah, this looks pretty typical to, pretty similar to the MacBook Pro. I think some things of note are, there aren't many openings here. Like, there's no speaker mesh or holes for the speaker there. Yeah, it's just a very clean design. The edges are kind of like really smooth and rounded over, so it's not very sharp. And the bottom looks like there are a couple of exposed screws here. I'm pretty eager to tap in. I don't know, Will, if there's anything else you want to add over, yeah, the changes between the M1 and the M2 MacBook Air.
Yeah, I think this is a totally new ID design here. I know that the wedge shape was really kind of famous, almost nostalgic for some people. And that was a laptop that, a lot of people have held on to for a long time. So I guess Apple's probably hoping this will be kind of the next generation of MacBook Airs that people will love and and keep for decades. But it just looks, my kind of first thought here is just it's compact. You know, as you said, you don't have those speaker grills, you don't have the M1 MacBook Air had no fan, so that had no active cooling. So I'm really curious to see, you know, when they put in the M2 chip here and up that power, if any of that changed.
And it looks like, again, just thinking back to the laptop teardown we did a couple months back, the Surface laptop, I remember that one actually opened up from the keyboard side, versus the MacBooks here have the bucket design from the back, which looks like Borzon is about to pop off. What do you think the trade-offs are, maybe from the audience as well, from what you've seen with other laptop designs? What do you think the trade-offs are of having it open up from the keyboard and assemble that way versus from the back?
Yeah, that's such a good memory, Tobias. You know, since I worked at Apple, I just kind of always remember laptops, you take the bottom plate off first when you're taking it apart, and just that surface was so interesting to see it completely assembled from the other side. I remember the enclosure on that was also magnesium, so it was like a totally different type of enclosure. A lot of cool design elements we dug into some of the cool machining that must have been done to get like some undercuts and stuff like that. So very, very different approach to a laptop architecture with that Microsoft Surface.
All right, Borzon, tell us about what you're seeing and feeling on that back cover there.
Yeah, it's a pretty interesting back cover. You know, normally you'd think there'd just be, you know, 4 screws, you take it off, you're ready to go. There are some snaps here that are pretty aggressive. You have to get a pry bar in and like really force them up. And I think we learned the hard way a little bit that those snaps are not all the way around the lid here or the cover. There are like these snaps on 3 sides. And then, you know, there are some clips down here at the bottom. So it's kind of a snap around these 3 edges and then a slide out. You know, I have to admit, the first time I popped this open, I thought the snaps went all the way around, and we were a little aggressive with popping off that last side here. So we lost some of these components. And they're, I don't know if you can see this on the camera here, but they're these basically stamped like steel clips that kind of interface with some screws down here on the hinge side of the body of the Air. And the screws are pretty interesting. We'll get into that a little bit later. But I did also note that the screws were different sizes on the bottom here. So there's 2 short screws and 2 long screws on the bottom, just so you know when you're putting it back together. I guess, yeah, I'm kind of interested to see some of these things in the app, but let's take a look at the inside of just kind of give a lay of the land here of the body. It looks like, yeah, we've got the trackpad on top, kind of our batteries here. And this looks like the main board. So I'm super curious to get in there. And then, yeah, down here we've got our speakers. Yeah, and then the hinges in the corner. Yeah, you could see a couple connectors on the side for like the different port modules. But yeah, I think, I don't know if there's anything we want to look at specifically in the app on this page. I don't know if you can really see this very well. That's one thing that I wanted to point out was, yeah, these clips interface with some posts that are in the body of the MacBook. So these are like custom screws that kind of have like a conical shape to them, and they have like a bit of an undercut. So when you're forcing it in place, they just kind of snaps down. So I'm not completely sure. I think it's like a really cool like design feature. I don't know. We could speculate about maybe why those snaps weren't all the way around. I think I'm also curious to know a little bit more about these clips down here, like the ones that I accidentally ripped off. Yeah, that's probably an unfortunate failure mode. I don't know if that's something that a lot of people experience. Just being a little too little too strong, spending too much time in the gym. Yeah, I'll pass it off to Will and Tobias. Maybe you have some comments there.
Yeah, maybe in parallel, let's take a closer look. Will Greenbaum, if you can pull up the images again. The initial thought is like, wow, there's a lot of different regions covered in black tape, and I think I can see the difference between the battery and the MLB. But it'd be great to take a closer look. If you want to stop sharing here, and Greenbaum can pull that up. Two interesting questions in the chat while we're talking about this. One from Will Stewart on the metal clips that I think you were referring to, Borzon, that a few of those popped up. How are those actually attached to the bottom cover? It was speculating adhesive or weld. Are you able to tell?
Yeah, you can pretty clearly see there's some adhesive there. Unfortunately, we don't have like a real easy way to see with close up. They're pretty tiny parts, but there's a little bit of adhesive, and then there's some like graphite foam there for conductivity or for grounding. And yeah, I think there's I don't know, I want to share my screen again. Maybe you might not be able to see it from my view anyway, but there's like a little laser etched cavity, possibly machined to lay that adhesive in. So like there's kind of like a little mini pocket there. But what's interesting about the clip itself too is, it has some roughness to it. It looks like it was maybe like laser etched, like they did like a raster kind of etch over the top of these, I guess over the bottom of these clips, maybe to promote adhesion there, give it a little bit more surface area. I am speculating, but I'm sure this was a pretty challenging thing to overcome, like getting the right glue, getting the right positioning and placement while fitting in this foam as well. I'm sure someone spent, ages testing and figuring out what like the tear off like strength, like the peel strength is. I did win in the end, was able to get one off, but yeah, I think it's interesting to think of like the trade-offs too, like other ways you can, attach something like this. Maybe, yeah, Will, Tobias, why would you not want to use like a spot weld for this? Yeah, that's kind of like the first thought is like, well, maybe we could like spot weld these together. Of course, they are different materials, so maybe that's the challenge. Let's
talk about that one as we dive into the close-up in the app, Greenbaum, if you want to pull that up.
Yeah, let me pull up some more pictures here, and then maybe when you're digging into the MLB, Will, you can pull up those clips again and see if we can get a close-up for folks.
Sure.
But I got some photos here that we can dig into. And first, I'll pause and just comment on where these photos are coming from. These photos are in the Instrumental app. So at Instrumental, we have this software platform that is designed to help with exactly the kinds of problems that engineers face, like how to attach these little clips in a robust way to an aluminum closure. So there's tools in this app for helping you find issues, helping you solve issues, and then at the end of the day, perhaps most importantly, hoping you learn from those issues. And that comes from lots of different data types, videos, functional test data. Today, we're just going to be looking at some images. We have some images in here already of this MacBook. And the clips that we were just talking about, these are the cool little kind of springy clip things that went over the screws that Will was showing us. And then on the other side here, we have these little steel pieces that kind of like toe in under some screws in the back. But maybe we can take a closer look at the glue bond on those. Great question about the weld. On the inside of the MacBook, here is the real guts. And like you said, Tobias, I just see black tape, which is clearly an Apple signature here. Looks like most of this is battery and trackpad here, which I actually think is really interesting because most other MacBooks, will have speakers on the side or something in the front here, and really just more than half of this thing is just battery and trackpad. So all of that functional guts is squeezed into the back here. You can see cowlings galore for every single connector attached to this main board here. This must be just one long PCB. Lots of little ports on the outside, which all seem to be their own little module, which is something we also saw in the Mac Studio, if I remember. So maybe that's a new standard. Would you guys think that these ports are like actually the same exact part? You know, you can swap out a Mac Studio USB-C with a MacBook Air USB-C.
I would like to think that there would be some universal part, but knowing Apple, my guess would be that there was some small tweak that required customization, and they actually have something independent here. But maybe in a couple generations, or maybe if they plan far enough ahead, maybe part of that module is actually universal, and then in the downstream assembly they add on either the enclosure and the flex to customize it. That would be my best guess.
Yeah, I bet those iFixit guys would love it though if those were all standard off-the-shelf parts.
Yeah,
swap around.
What are the various modules we see down on the bottom of the image, Will?
Yeah, this is really interesting here. So this looks like a speaker to me. You have your diaphragm in here. This here in the middle is this kind of gold black module. What do you guys think this one might be? It looks pretty different.
Yeah, we'll see. I think I have a pretty good guess, but we'll see if the audience can guess. I spy a tiny little cable that's popping out of the right side there. Yeah, that might give it away there. Yeah, I think Philip, Ron. Yeah, three for three. Vote for antenna.
Yeah, the coax cables are definitely a good sign of that. And then, yeah, here in the middle, we have a nice big cowling. This is probably where there's a connection up to the display side of the product. And yeah, a speaker on the other side here. And this is really interesting because I don't remember seeing any holes on the top by the keyboard. So I'm curious how these speakers actually vent to the outside. I think with the Surface we took apart, the speakers actually played through the keyboard. And that was a pretty interesting design. So I'd be curious to see if it's a similar thing here. And then the last thing I just noticed is, there's no fan. We were wondering about the thermal design of this, and there's no fan on this. So it's all passive cooling, which makes this big piece of graphite tape just really, really critical. And it reminds me of a story. This one looks pretty well assembled. It got shipped out to customers and looks pretty good, but it reminds me of a story with another customer of ours who was using tape. And when tape is, critical to the function like this, I can actually come over here and show an example of it. It can be really tricky because it's usually assembled manually by operators. So here, jumping over to another product here, this is an example of a kind of more like a GoPro camera. There's this critical piece of tape here that was used kind of like a cowling to hold down this connector, as well as insulating some of these other components and protecting them. And going through development, we had this customer that was having problems with reliability. These connectors were popping off, and they were really confused because, we have this tape to hold it down. How is this coming off? They went in and they kind of drew a box, did this anomaly search, and they were able to see just a huge amount of variation on that tape. And what comes up here, we have one part that's completely missing the tape. We got some wrinkles here. This one is just torn off. This one looks like almost looks melted. And then this is perhaps the classic one, is that gets assembled. You get this kind of tear here in the corner. So and then they were able to actually correlate it, and I'll show a little bit more about that later, but correlate it to a specific operator that had assembled that tape. So they were able to take these photos and use them to train operators a little bit better and make sure that that tape was getting assembled well. But looking at this MacBook, that's kind of one thing that pops to mind, is like that graphite tape must be really, really important to the thermals.
Yeah, that's a great call out. It's unfortunate the number of issues that I have in my memory that have been root cause to either manual assembly or some type of operator variation in
Tapes and glues.
All right. Let's I'm curious what Will Borzon has uncovered here. What's underneath all of that black? Did we make some progress on taking out that MLB?
We did.
Yeah.
Yeah, I can see, we removed a lot of cowlings here for like all of the different flex connectors. Maybe you can see a little bit better here. Yeah, there are like 10 to 12 different flex cables. I already lifted a couple up, but you can see as you're going around, there are a couple down here. There's some like 2 antenna connections here. Looks like that's leading from, this black and gold component on both sides. So I think the antenna is the right idea, but it looks like those are attached to the speakers as well. So that's a pretty interesting component. I think I'd like to dig a little bit deeper there. But then, yeah, we've got flexes all the way around for all these different modules. I'm curious about this one. This is another flex that's kind of folded over itself, and it kind of pops through the shield there. So I think I'm just going to try to peel this one out. I know I'm probably, I hope no one's cringing at, or I hope if there's a designer of this board, I'm being a little aggressive with some of these bends. So
This is a one-way teardown. We're not planning to rework this one and ship it back.
yeah, I think it might be a one-way. This one doesn't want to come. Let's see if we can fold it up.
Pop it up there. And while
I don't know if you can see that this component, I know someone asked a question about, the glue on the other side of that clip. I'm not sure if you can actually see that very well. Bring it really close. It's basically just all around that backside there.
while you're taking that one off, Will, here, exciting announcement for next month. We're doing an exclusive in-person edition of this teardown. I know you guys love watching our little boxes of faces on Zoom here, but you can see we're actually in the office today. And next month, December, I believe it's December 7th, we'll post some links. It's going to be an in-person teardown. We'll have games. There's going to be a little networking hour before. So we did one of these before. It was a ton of fun. Highly encourage anyone that's in the Bay Area to join us for that live teardown.
And then you get to play around with all the parts yourselves if you have follow-up questions about any of the pieces.
Great point. Yeah. All right, we got it out. Here's the MLB. Looks like there's a really large shield can on it. I might work at kind of prying that off when I hand things back to you, Will. But when we lift it up, it looks like what is revealed is kind of a secondary board here. Kind of theorizing that that's some kind of audio board, audio breakout. But there are some other things connected to it that I think we can only uncover when we take out this component. Yeah, and it looks like this hinge, there's some kind of hinge cover here that's kind of like pinning this in place. I think it's hiding an additional screw here. So I think I'm going to take these both off to get a closer look there and take a peek at the underside. But yeah, I think we did take some images of the board in the app. But in the meantime, I can take a stab at removing this shield. It is quite a lot of work because it covers the entire PCB. So it takes some finessing, but
what's going on, Borzon, on that side of the shield that is overhanging the main PCB there?
Great question. It looks like this right here is like a reinforcing component. Yeah, like these like slots are used to kind of tie this shield like to the frame here, but there's a lot of empty space. Actually, this is like a bracket to prevent it from, getting like totally squished down, because there's a bit of like a cavity in this area here. So I'm super curious to know if anyone maybe in the that might be watching has any ideas like why there's so much excess space here. I think we originally were theorizing that, maybe this isn't going to be, there will be many MacBook revisions, maybe M3, M4 so forth. Maybe they want to leave some space for some like future component, or maybe something was left out. Maybe they pulled it at the last minute. Yeah, curious to know if anyone in the audience has any ideas about why there's so much space. I think that's pretty atypical for an Apple project, to have so much like space in this location. But I think we settled on, I guess the Apple engineers needed to get air in here somewhere. So maybe this was the air component that needed to make it into the Air. Kind of maybe a spiritual requirement for the product.
Like
yeah, but we can maybe take a closer look at the MLB, Will, if that's.
Yeah.
I bet
Miguel
was guessing placeholder area, which I think was similar. I know in some other products as well, we had seen different SKU variations have slightly different components, but I don't think that's actually the case here. I think most of the SKU variations are just memory and processor, which would just be chips on the MLB. So I don't think that would explain the gap.
Yeah, just to take a closer look here, this is where that main MLB was, almost kind of like an iPad board here, just kind of tucked in the corner. And then we had the audio board here, and then all of this was just covered empty space. So maybe there's a surprise coming for us one day in the next MacBook Air. All right, let's pull up that PCB here. This is where all the magic happens. I mean, you know, this is why Will had a little bit of a tough time getting it open. We have connectors all around it here. I think we found our antenna connectors here. We have over here this weird little flex that connects this main board to this audio board. I was a little surprised to see that, to have those two boards right next to each other, just connected by a flex. You guys have any thoughts on why they were just separate boards rather than one long board?
I'd be curious to hear from the audience on why they might have split out a separate audio board. I'm not an audio expert. I had a few thoughts. Oh, Miguel's thinking rework. That could be interesting. That would imply that there were maybe a larger amount of rework or failures specifically on the audio board to make that more easily serviceable. That's an interesting thought, because yeah, you wouldn't want to have to rework the entire MLB. Service purposes, that's another interesting hypothesis here. Yeah, I think there's a lot of interesting theories. Another one could be they're at slightly, it could ease the overall assembly. It looked like the audio board was slightly offset, and so maybe it actually helped that they were both modular. But Will Greenbaum, do you have any thoughts on that?
Yeah, the only other thing I can think of is maybe a long, skinny board might be a little bit challenging from a reliability standpoint. Might make it really bendy and things can break, or it could be a cost thing and have to do with the ability to panelize these boards efficiently and make as many as you can. And having kind of that little board sticking out made it a lot harder, or a lot more expensive to make these in mass and very high volumes. But whatever it was, they combined it pretty easily with that flex here. Other connectors that we saw here, I think this guy was our trackpad. So one looked like a battery connector, and then we have a bunch of connectors on the ends here for the ports on that side. And coming back here, there were a bunch of connectors here for the ports through the audio board. I'm really curious to dig in more to these corners a bit more with the speaker and the antenna. But Will, do you have a chance to get that shield off, or should I take a look at it here?
Why don't we take a look here? I was able to investigate that corner a little bit more, but the shield is giving me a tough time.
Yeah, I mean, again, no active cooling here. So this shield is actually a very functional component, and there's clearly a lot going on here. I mean, let's count them just for a second. We have 1, 2, 3, 4, 5, 6, 7, 8, 9,
That's
10, 11, 12, 13, 14 tapes and foams. This looks like some kind of welded on bracket that you were pointing out earlier. We have thermal paste on here. This thing is like a module in itself, and must have a lot of different functions. Some of these shiny tapes, there's kind of shiny tape and dull tape. So it looks like 2 different kinds of tapes. You guys have any experience with these tapes? Thoughts on like what the difference might be between them?
Yeah, I'd love to hear from the audience on the tapes. My initial thought, it's a really interesting, the thermal paste there, thinking back to all the different teardowns that we've done, again, a lot of different thermal management. This, I think, is the first black thermal paste that I've seen. Most
Classic Apple,
like sort of a dark orange. I've seen the whites, either thermal paste or thermal pads. They always have a unique color, but they must have very intentionally made a custom black thermal paste just to keep the internal ID, which, you know, gotta give them some credit for that. It does look nice.
It does, yeah. Thermal paste, though, is just a constant headache for a lot of our customers. It's one of those things that is really critical functionally, and then it gets put on and then closed up with a can over it, and then you never see it again. So I was kind of curious about how many other people here have struggled with parts like that. We have an example here in this product of this thermal pad that went on top of the main processor, just like in the MacBook. And it was causing all sorts of problems because it's, you know, manually assembled part. Even if it's dispensed, there's a lot of ways it can go wrong. And the thermal tests that you run parts like this through can take a very long time. So this was a case where this customer had a lot of functional failures. And if we dig into this here, they were trying to figure out, is the thermal pad causing these functional failures, or is it more of a design issue, or is it an assembly issue, is it a quality issue, process issue? They really couldn't tell. So with Instrumental, they were able to use visual correlations. This is one of my favorite features here, to have all these failures look against all the different areas of the product where there's visual anomalies. And here they were seeing a region on the thermal pad. They want to see, you know, do these failures correlate to the thermal pad? And there was actually a spot here. They had the kind of this weird cutout due to mechanical space reasons, that this tab was actually getting damaged in the assembly. And so they were able to adjust the design and the process to make sure that this little tab on the thermal pad was not kind of getting broken like this, and make sure that they were able to actually get like the thermal performance they were modeling. So I imagine the same problems were present on the MacBook here, getting that thermal paste just right, maybe the volume of it, the position of it, all of that must have been really, really tricky on this design, given that there's no other form of cooling.
Yeah, thermal management, I think, comes up in just about every teardown that we've done here. I'm always baffled by the different edge case thermal failures that we see. Anyone in the audience, as we're talking a little more about thermals, would be great to hear what your thermal management horror story is, or what sort of thermal management you've dealt with. I remember one of the biggest things, Will, that you were mentioning is the amount of time the thermal test takes. I remember the burn-in tests that I think they were 24 hours or so. So yeah, it's a very lengthy test. And when something fails that, exactly like you said, it's pretty difficult to be able to root cause that. So yeah, having that historical data record to actually go back and automatically correlate like these assembly processes, the thermal dispenses, that would be hugely valuable.
And, you know, doubly so if Apple was trying out some new black thermal paste. Probably had to qualify that with a lot of different experiments to make sure they were getting the performance they needed. So I wouldn't be surprised to hear that there were some stories behind that.
Yes, even something as simple as a color change needs some new qualification.
All right. And then, yeah, before I turn it over back to you, Will, just showing the the fun side of the board here, we have the M2 chip. This is the powerhouse of the whole computer. It's just amazing how small these things are these days. Over here, it looks like we have, my guess would be this is just memory and some room for extra if you want to do an upgrade. But these are some beautiful encapsulated, shielded chips. So everything is just inside of this big, giant shield can, except for this. So I'm very curious why this guy got kicked out and is on the outside of the shield can. It says USI, and with these little coax connectors here, it's probably something to do with the antenna chip. But yeah, any guesses from the audience on why this chip is banished outside of the shield can?
Yeah, Miguel thinks antenna.
You know, I think 9 times out of 10, saying a decision was made for an antenna is a good reason.
Yeah,
the proximity to the coax connectors there. I'm sure that's it.
But yeah, I mean, the other thing I got to note here is just how orderly this board is. All these components are lined up, and it's a piece of art in itself. I can only dream of the amount of work that goes into making these boards just perfect like this. So the black thermal paste makes sense now. You don't want to, tarnish this beautiful board with some ugly pink thermal paste. All right. Well, as I said earlier, I was really curious about these corners here. So I'll turn it over to you, Will, and see if we can dig into those a little bit more.
Yeah, let's get back in there. So I was able to get that shield can off eventually. I don't know if there's anything interesting you'd want to look at, but we do have it on deck, as well as, yeah, this huge shield can over here. But yeah, that's on deck if anyone has any questions. In order to take this antenna module out, you have to remove this cover. And it's kind of interesting. I mean, it's a pretty complicated part. I mean, first, it's, the stock volume that it would be theoretically machined out of would be like fairly large. I mean, you can see that it looks like, almost like a sheet metal part with like how that tab is bent up, but it's very clearly, machined or some other manufacturing process. I was thinking, like, is it possible that this could be injection molded? But I think it was probably machined in the end. And you can see like these tiny little grooves here just to provide enough space for these larger screws that are on the hinge. So this is a pretty fascinating part. And we don't really know exactly what the purpose of it is. I mean, it's an internal component, but with all this machining, I don't know. Have you ever seen an internal part that's, bead blast anodized, machined like this, Tobias, Will, in any of the like former products that you've worked on?
I can't think of any.
Yeah, a lot of effort going into something that the customer, like the user, never sees. It's pretty interesting. I think we're thinking that maybe it could be like a reinforcing component. There's a lot of air here that you might want to cover. You might like, maybe this can serve some kind of structural purpose, but with only one screw. Yeah, that's it's a little bit unusual. Curious to know if anyone out there in the chat has an idea. But when we remove this cover, it exposes a screw here and a couple of screws here. These screws actually are custom. I think every screw here is custom, but these are the ones that interface with the clips for the back cover. Again, hard to see here, but if I were to draw the shape of this screw up in this corner right here, maybe right here, it kind of looks like this. Some live sketching, love it. So those clips just interface here, and they're attached to the back cover. So they're like pretty fascinating. You guys should all come to the in-person teardown, and I'll give you a little bit of a tour there so you can see them up close and personal. But once those are removed, we can finally take away the antenna and speaker module.
Wow, that's all one piece?
Yeah, one piece. Pretty interesting. I've never seen an antenna and a secondary component just kind of like on their own. Yeah, I'd be curious to hear your experiences with this, Will, Tobias, and the app. But before we go there, I just wanted to point out there's this one speaker here, like the larger one, and then I think there's like a tinier one here as well. And I didn't show it when I was first giving the tour of the MacBook, or the Air, sorry. But there are some openings in between the screen and like the keyboard body that are kind of serving as like the only, I guess, ingress egress area, like a speaker grill. I think that's the purpose is basically for audio. I think there might be like some microphones down here, kind of close to the center of this hinge location. Yeah, I think maybe I'll hand things back to you so you can take a closer look at this module in the app, Will.
Sure. So you're saying that the speakers actually fire out through the hinge to the display?
Yeah. Let me see if I can get a quick view of that. It might be tricky, but we'll give it a shot.
I know David was asking earlier about those microphones as well, and Ron had some theories on the speaker, maybe even using part of the housing or the backplate for resonance. I'm not sure about that for the speakers, but are you able to see the grills there?
It's really hard to see, but right in the center here, there are 4 openings on the left and right side that line up perfectly with these speakers.
I think I saw it just for a second reflected off of the display. There were a couple
Oh,
of
nice.
spots.
That would be cool.
Yeah.
Yeah, maybe we could use it as a mirror. Good thought. Oh, here we go. Let's see. Oh. Can you see it?
Yeah, that's gonna be tough. That's gonna be tough.
Maybe too tough.
All right, let's dive in. Yeah, well, I'm curious to take a closer look. It looks like there's a ton going on in that lower corner, even behind with the hinge behind the speaker. It looks like there's some other flexes and stuff.
Yeah.
Too. What are we looking at?
Well, let's take a look at that speaker quickly. So we have the speaker you mentioned here, and then on the other side, there's this little tiny speaker. So Miguel called out that it was quad fire. I guess that's some of the marketing terms here, but there's actually 4 speakers in this tiny little MacBook, which is impressive.
Wow.
And then this flex that's run over the antenna here, and that looks like it's probably to drive the speaker, but it's all kind of assembled into one big module. And some pretty interesting things on this part here. This antenna, you can see actually 3 different colors. You have some kind of gold plating here, then some kind of like solder layer here, and then yet another brown layer on top of that. Have you guys seen an antenna like this before?
The triple layer is interesting. I just assumed it was sort of a standard LDS antenna with a molded part and then the actual conductive antenna part. But the 3 layers is interesting there. Can you tell what the coax is actually connected to?
Yeah, that's a good question. Maybe we can see it on the other side here. Well, it looks like it runs here, and it kind of terminates under here. But yeah, if this was like a solid molded plastic, then this outside of the coax is all like soldered to this layer. So that would be a ground layer. I can't really tell though. It's definitely an interesting design to see how that antenna works.
Yeah, maybe we'll rip it apart more at the in-person teardown next month. Try to peel off one of those layers and see what we find.
Yeah. But there's lots of other stuff going on in these corners here. So this is where that speaker came out of. You can see that bracket here, the hinge here that was covered with the bracket. Let's see if I have a before and after. That's that little piece Will was looking at. And then this looks like our Touch ID module here in the corner. And then this flex here, this I don't think I noticed this originally. This runs into the corner onto the hinge itself. So maybe, I don't know if that's a microphone or something else. Did you get a closer look at that, Will?
Yeah, that that flex cable goes right to the end of the hinge, and you can see like a tiny little component on a flex that's like deep inside this cavity. Looks like it's right on the axis of rotation. Just sharing a little bit of background. When we first opened the Air, like removed it from its packaging, the first thing you do when you lift open the lid or lift open the screen is the computer turns on immediately. And we're kind of speculating that maybe this is some kind of hinge state detector that could basically trigger the computer to turn on for like the first setup or something, just to make that unboxing experience super personal and exciting. But yeah, I'm wondering, we tested around like the perimeter of the Air, like searching for like a magnet. Most of like the MacBook Pros have kind of like a Hall effect sensor or some kind of magnetic sensor, in the body to detect when the lid is closed, so you turn off the screen and things of that nature. And I'm wondering if they've switched over to like a hinge angle to basically serve as that sensor instead. Maybe it saves some space elsewhere. Maybe you don't have to have like an additional magnet elsewhere in like the body. There's not a lot of space near the batteries. Maybe you want like some additional space for those batteries to contract and expand. But yeah, I think I would be interested to know like what kind of sensor that is. I don't know if we'd be able to tell today. But
I'm thinking, yeah, I think you might be right, because I remember in most of them there was the Hall effect sensor. I bet that's either an optical encoder, it could be using that to do the angle sensing, or it could be some form of Hall effect sensor as well, sort of a more simple, just open closed there. So I think you're onto something there. I am curious on the point you brought up before, the feel when you open the lid. It still has the same snapshot. And so Will Greenbaum, I'm not sure if you can look around. We were looking for magnets around
Yeah,
the
I was just
perimeter.
looking around the edges here, see if I could find magnets. Is that what you were thinking?
Yeah. What do you see? Because when we did a little magnetic test, we didn't actually find any magnets there, but it almost looks like there's something on the perimeter there if you look on that undercut.
Yeah, I'm really curious about this guy here. I mean, that is, first off, this in general is just a lot of space. That could be a battery, but it looks like that's these kind of battery tabs here. But then underneath, I have no idea what this piece is here. I mean, the first thing I notice is that this is just machined out pocket that is shiny. So it's after the anodizing. So that's kind of strange to have that so late in the process. And then it almost looks like there's an undercut there as well, really looking at this corner here. I'd be really curious to see if that's just a big long magnet or what that's for. But it really,
when you're looking at it in person, it looks like it should be a magnet. Like it's got kind of like the finish of like a raw magnet that you buy from McMaster Car or wherever. Like but it's, I don't think it is. And then I think the other, like it also looks like just key stock, like that you put in like to mount a gear to a shaft or something.
Yeah.
It almost looks like just the stiffening component that they've just machined all this area out and have added these stiffeners in that are a different material altogether. It's really hard to tell. I mean, I can't pry them out at all. I think they're glued in there. But I suspect it's like, yeah, a stiffening element, and you can see them on the sides too. to the left and right of the kind of square batteries, there are additional like reinforcement pieces. And yeah, it's overall just kind of interesting. I wonder, that's like a heavier component too. Like, are they trying to, maybe it's like a balance in some way too, to kind of give it like a, there's a lot of weight, maybe, biased towards the hinge side, by putting some steel stock out, in the front of the device, it's like a little bit lighter. Maybe you're kind of, evening out the overall feel. Because I mean, it doesn't feel like it feels like the center of gravity is like in the middle of this air, not like, I guess like closer to the hinge down here or anything like that. So I think maybe it could be like dual purpose.
That's a really interesting idea. It'd just be funny to me. You have your MacBook Air complete with air and like steel rebar.
Yeah, pretty interesting. And no, it is not magnetic, or rather, I don't think it's. I think the material is magnetic, but I don't have like an actual magnet on hand. Yeah, I think it really feels like steel to me, like a stainless.
Yeah, great, Greenbaum. While you were that just reminded me, while you were annotating that picture to highlight some of those, I know a lot of our current customers are utilizing this new feature, especially to communicate with their overseas CMs, because it's so much easier than popping your email or popping your image into your email and like drawing on it manually. Do you want to show briefly some of the features around just how easy it is to highlight? And then I know a lot of our customers are also using the commenting feature to use this as sort of an issue tracking, failure analysis platform.
Yeah, no, the annotation is really great. When I was a PD engineer, I would probably spend half of my day just taking screenshots of things and annotating them and putting them in slides and emails and whatnot. So being able to do that here straight on the image, and then that URL takes you right to it. So you can just kind of text that to someone, throw in WhatsApp, WeChat, whatever. And you mentioned the comments. That's another great one here where I can also tag, you or any other coworker here, like our friends at Change Notice, and they'll get an email immediately sent. So I don't have to spend any time drawing on this, trying to put it in a slide. What goes along with that is also measurement capabilities. So if you want to, measure the diameter of something here, you can also throw that in there and then say, measurement A, and then send that over and say, please go measure this on a couple parts. Or coming up soon, we have the ability to do that ourselves right here in the app with some machine learning powered measurement tools. So maybe next time in December, we can show off a little bit more about that new capability.
And what's really awesome there, what a lot of our customers are excited about, is you can retroactively measure thousands of parts and then correlate that to some performance metric. And I remember the one that really sticks with me is, again, back to the antenna. How do all of the positions and gaps affect the antenna performance? When this PCB is moving around, how does that directly correlate? So that's an extremely powerful tool that we're just releasing with some of our customers. So we have just a few minutes left. So there's a lot more that we could talk about. Any final questions or specific components you want to make sure that we cover, please post them in the chat here. Anything else in that lower corner, Will Borzon, that we want to highlight?
I mean, the nature of this flex is pretty interesting. I mean, yeah, you're going over this module. I think it's like glued on top of this module here, almost part of the module itself. So I think that's kind of interesting. Yeah, there's some like Will pointed out previously, there's like some raw aluminum unanodized, suggesting that it was post machined here. And yeah, it's not completely clear. I mean, maybe there are some really key dimensions there that they don't want to impact with the variable thickness of an anodized coating, or maybe they just want the conductivity for grounding the hinge to the body of the laptop overall. That could be something too. I don't know. I'd like to see if there are any specific questions while we have just a couple minutes left about what's in front of me, or if there's anything that you're a little bit curious about. I know we don't have a lot of time to dig into like the trackpad, but I think there are a couple of other teardowns that this trackpad seems pretty similar to a lot of other laptops, like maybe kind of a standard part or a kind of configuration for a lot of Mac products. So we won't go too much deeper there, but yeah, I think a couple of other things that I noticed and just wanted to briefly point out where I think this battery tray is, these batteries are mounted to like a tray. This kind of like drops into place. And I think they're held captive by these screws that interface with the top lid or the top cover. So this is like providing that snap feature. But also, I think this is also a different material than the aluminum. And just to give it a little bit more structure, you've cored out so much material to fit all these components in here. How are you going to get your rigidity back into the product so you don't have, you're not facing another bend gate or other crisis? I think the way they're doing that is through kind of additional components to provide some stiffness back in to make up for the loss of stiffness with just the machining. I think the back cover provides a lot of stiffness too once everything is seated in place. But I'll pause there. Maybe there's some questions. Maybe Will or Tobias, you could float some out there because I haven't been able to moderate the chat very closely.
Yeah, there's a couple great follow-ups. I think Charles was asking about the trackpad. I think that's a great one for the December event. Again, we're going to have all of these parts available. We can continue taking out that battery tray. We can look at what's underneath there. So I think we have just 2 minutes here, and I want to make sure we're able to wrap up. Again, this December event, forgot to mention the most exciting part. We're actually having a special guest speaker, David Kalinowski. He's coming, and we're going to take apart the Google Pixel Watch, just released. So super excited to tag team that together. Again, that's in person in our office, December 7th in Palo Alto. There's going to be fun. There's going to be, I think, bingo and prizes and other surprises along the way. So we'll post some links in the chat there. And again, so thank you all of you guys for participating. We love to hear your questions and commentary along the way. Survey at the end. That's how we decide what we're going to take apart next. So please, please, please fill that out. And if you want to learn a little bit more about some of the tools that Instrumental offers that Will was showing, feel free, just email over communications@Instrumental, and we can give you a more in-depth demo of how we can help some of your manufacturing processes. And with that, we'll wrap it up here. Thank you everyone for joining. Thank you, Team Teardown. We will see you guys December in person. Take care.
Thanks, everyone.
Manufacturing has changed, and hitting yield targets, deadlines, and quality goals is harder than ever. Instrumental is the first manufacturing optimization platform designed to help both engineering and operations teams ramp successfully on every program by finding and fixing issues at the source and making sure they don't come back. From development through mass production, Instrumental is helping the world's most innovative brands and contract manufacturers accelerate failure analysis and drive continuous improvement by easily unifying their product data into one secure cloud-based hub. And you can get started in less than 1 week. Using images, video, machine parameters, functional tests, measurements, supplier and return center data, Instrumental makes collecting data and finding correlations easy. Our AI surfaces the most meaningful relationships among your data sets, so you can find the root cause fast. Starting with your first build, Instrumental proactively identifies new issues by scanning your products for anomalies in visual or functional test data and automatically delivering net new discoveries. In development, engineers can jumpstart failure analysis with defects in context by leveraging a rich, remote data set. With Instrumental, they can quickly identify correlations and potential root causes, and even push live tests to validate solutions immediately, eliminating issues at the source. In mass production, you can monitor throughout, get alerted of shifts, and identify correlations to root cause, unexpected drift, redundant tests, and operator issues. When installed across factories in a supply chain, brands and suppliers are able to stop working against each other and start working together to solve their most complex issues. Better products start with better data. Better products start with Instrumental. Schedule a demo today.